So the general form of a quadratic function, everything is multiplied out. So there are no parentheses. It's just ax squared plus bx plus c. If you have a quadratic, a will not be 0, because if a was 0, then you wouldn't have an x squared term. If you have a graph of a quadratic, it's going to have that U shape. So you're going to have either an upside down U, and that occurs if a is negative, or you're going to have a right side up parabola if a is positive. And quadratics are really fun to study because they model projectile motion. And projectile motion is used all the time. So if we launch a rocket, that is modeled with projectile motion. If we throw something in the air and it comes down, that's projectile motion because gravity follows a quadratic model. If we hit a baseball, that can be modeled with a quadratic. If we have a rainbow, if we have a water fountain, half of it. So many things can be modeled with quadratics. So it's kind of a fun thing to study. So the domain of a quadratic function is all real numbers, because you can square any real number, you can multiply any real number by any number. So any real number is part of the domain. Now, in terms of the other forms of quadratic functions, you have what's called intercept form, which is also called factored form, depending on what which way you want to look at it. The intercept form is really good if you want to graph the intercepts of a quadratic function. So the intercepts are actually the x-intercepts. So if the graph crosses the x-axis, you can write the equation in intercept form, and it's going to be a lot easier to graph it if you have it in intercept form, if it is able to be factored. So the way you get it into intercept form is you factor it, and you would first factor out the greatest common factor, if there is one, which would be a, and then you factor it just like you would normally using like the snowflake method or whatever makes you happy. Then we have what is called vertex form. Vertex form tells you the vertex of the parabola. Now the vertex of the parabola is the point in the parabola in which you change directions. So it can be also called the apex of the parabola. So when you think of like the Angry Birds, this is the vertex right here. So it's the point in which the bird goes from increasing its height to decreasing its height. That's the vertex. Or if you're looking at, let's say, upwards parabola, the vertex would be right here, because that would be the point in which the object, if you're modeling its motion, goes from decreasing to increasing. So that is the vertex. So if you have an equation written in vertex form, you can very easily tell the vertex because the coordinates are given by h comma k. That's one of the benefits of vertex form. And the way you get an equation into vertex form is by completing square. So we'll talk about how to do that. So you can put any equation into vertex form. Intercept form, you can only put it into that form if there are x-intercepts. A parabola doesn't necessarily have to cross the x-axis. It can like float above the x-axis or kind of go below the x-axis. So not all these forms are possible. Any questions so far about parabola? Now, we have different parameters in parabolas, but all of those parameters, all of those different forms had an a value in them. We had standard form, which was y equals ax squared plus bx plus c. That had an a. We had factored form, which had y equals a times parentheses x minus e. Yep. And so that had an a. And then vertex form also had an a. So a was present in all of the forms. And what a represents is how stretched out the parabola was. So it represents, and depending on how you want to look at it, It can be a vertical or a horizontal stretch. But the way you can think of it is that if the parabola has an a value that is greater than 1, you're going to have a skinnier parabola. So take a look at this diagram. The blue parabola is your standard width parabola where the a value is 1. With that standard width parabola, from the origin, you go up 1 and over 1 to get to 2 different points on your parabola from your vertex. So if I go up 1 and over 1, I reach 2 sides of my parabola and my standard width parabola, because for this the a value is 1. If you have a skinnier parabola, for this one, a equals 3, because it's y equals a equals 3x squared. Now let's take a look at the black parabola. For the black parabola, if I start at my vertex, if I start there and I go up 3 units, 1, 2, 3, and over 1, I'm going to reach 2 other points on my parabola. So I can go up 3 and over 1. And that makes it a skinnier parabola because it is stretched vertically by a factor of 3, because you're multiplying by 3 on the outside of that parabola. That's what makes it skinnier. So to graph this parabola from my vertex, I go up 3 and over 1. And that gives me 2 other points that my parabola travels through. So skinnier parabola. Now for the pink parabola, a equals a half. Now this one's a little trickier because it's not up 1 over 2, as one would think when one would graph lines. It's up a half over 2. I'm sorry, up 1/2 over 1. This is a rule with parabolas. We're not graphing lines, we're graphing parabolas. So if I go up 1/2 and over 1, up 1/2 and over 1, this is a rise of 1/2 right there. I'm going to meet 2 other points that my parabola travels through. And that makes it a wider parabola because I'm only going up a half and over 1. So then the parabola is compressed vertically by a factor of 1/2. So it is a wider parabola. So if a is between 0 and 1, it's a wider parabola. And if y is above 1, it is a narrower parabola. So the a value tells you how far to go. So let's say a equals 4. So for example, y equals 4x squared. You would go up 1, 2, 3, 4, and then over 1 in both directions. Up 4, over 1. And because the parabola has that y-axis symmetry, because it is, in this case, an even function, that's why you go both right and both left. Up 4 and over 1. Now, would I continue that pattern? Would I go up 4 and over 1 again and just keep going up 4 and over 1? No, it's not a straight line. It's not a slope. You only get to do that once. If it was a straight line, it would be like an absolute value function. It would look like a V. So we just keep going up 4 over 1, up 4 over 1, and that would look like a perfect V. This is a curve. So you can only do that once. Likewise, if I had like an a value of 1/3, for example, y equals 1/3 x squared, what you would do, this is 1, 1, 1. Wow, that was a bad one. 1, 1. I would go up 1/3 and over 1 and 1. So that's going to be an even wider parabola because I go up 1/3 over 1. This is 1/3. That is super tiny. I apologize. Can you guys read that little 1/3? That is so small, sorry. Up 1/3 over 1. And if you have a standard parabola, your standard parabola, y equals x squared. This is really cool about the standard parabola. You go up 1 over 1 and 1. Okay? Because your a is 1. Now, if you want some more points, you go over 2. And how many do you think you go up? Yes. 4. Because what's 2 squared? 4. So, answer might be fun. So you go over 1, up 1. Because 1 squared is 1. Over 2, up 4. Because 2 squared is 4. Over 3, up 9. Because 3 squared is 9. This is a parabola. So it's a squared function. So 2 is 4. 3 is 9. So you could just keep going like that if you want a ton of points. So instead of just drawing a random u, it's the squared function. So 1, 1, and then 2 is 4. You have your nice little, that is not nice. This is everything in the negative. Okay? If you have an a value, which is negative, it flips everything upside down. That is your x-axis reflection. And we learned about those when we did function transformations. If a is negative, it flips it upside down. So same thing, it's just we take it and we flip it over the x-axis. And that's what we have in angry birds, because there's gravity. Just throw it up and then that. Questions on that? All right, so for graphing a quadratic function, if we have a quadratic function in standard form, that's that y equals ax squared plus bx plus c. Any quadratic function has an axis of symmetry, meaning you have a line, you can draw through it, in this case vertically. There are sideways parabolas, but we're not going to talk about those quite yet. And that axis of symmetry is the line that goes straight through the vertex. And the way you calculate where the axis of symmetry is located, also where the vertex is located, is by doing x equals negative b over 2a. The reason that this is true is somewhat related to, well, it's directly related to calculus. It's also directly related to the quadratic formula. Remember the quadratic formula? X equals negative b plus or minus the square root of b squared minus 4ac over 2a. So if we take away this part, that is the point that we're not deviating from the center at all. We are in exactly the middle of the parabola when we take away the discriminant, negative b over 2a. So the vertex is at x equals negative b over 2a. That's how you calculate the center point of your parabola, where your parabola changes direction. Any questions on that? You guys ready to do some graphing? Okay, we'll just take it till we get here. Okay, so we're going to graph this parabola in 3 different ways. We're going to first do it in standard form. Then we're going to do it in vertex form, and then we're going to do it in intercept form. So standard form, just to remind you, is y equals ax squared plus bx plus c. So consider the orientation and the width. The a value for this is 2, because it's 2x squared. So that means it's an upward parabola. And that means once we get our vertex from there, we're going to go up 2 and over 1 to get to 2 other points that our parabola travels through. Now, to find the coordinates of our vertex, the vertex is a key point in our parabola. We conjure the equation x equals negative b over 2a. Well, negative b in this case is 12, because b is negative 12. 2a is going to be 4. So the x value of our vertex is 3. Now the vertex is a point, so we do need to know the coordinates. So if I know the x value, how do I find the corresponding y value of the coordinate? Ashley? Yeah, you have to plug it into the equation. So if x equals 3, we're going to calculate y by plugging it into the given equation. So if x is 3, y is negative 8, so that means my vertex is 3, negative 8. So now I know my vertex. So that is going to be the bottom of my parabola. Now this is an upward parabola, so that's going to be the minimum value of my parabola. I can plot my y-intercept. My y-intercept is 10. And I know that because to find the y-intercept occurs when x equals 0. And that's real easy to find when you were in standard form. So there's your y-intercept. So I can actually get a bunch of points at this juncture in my process. So I know my vertex is at 3, negative 8. I know my a value is 2. So from here, I can get 2 other points by going up 2 and over 1. Up 2 and over 1. Because a value is 2, I can glean 2 points from it. And honestly, I can get a bunch more if I want to just kind of follow the direction of the parabola. But I really can also take another thing into consideration. There is an axis of symmetry that we talked about. The axis of symmetry cuts the parabola in half through the vertex. I'm going to draw it. Right here, that's really dark. I'm going to pretend I didn't do that, and I'm going to do it dotted. And then I'm going to move it back over. So this is called my axis of symmetry because it symmetrically cuts my parabola in half. Now, do you guys notice that my y-intercept is 1, 2, 3 units off of my axis of symmetry? Do you see that it's 3 away? So that means I have a corresponding point 1, 2, 3 units on the other side. Because a parabola is a symmetric, very symmetric in terms of vertical symmetry in this case. So if you have a point 3 units away on the left, you also have a point 3 units away on the right. So you can add that to the mix. So now we have 3, 4, 5 points. We have the vertex. We have the 2 points we got here because a equals 2. I went up 2 and over 1. We have the y-intercept. And then we have the other point we got because of symmetry with that y-intercept. All right, any questions on this? Where's our parabola? How are you feeling? Great. Maybe your birds took a little long today, so we're just going to call it a day. See you tomorrow. Thank you. You're welcome. Good, one more. I didn't get far down.
I don't know. It's really fun. Go sit in the front row. Nice.